We're supposed to find the second derivative of this function and then evaluate it at 4. Find the second derivative and then evaluate it at 4. Before we do that, let's first rewrite this function so that it's just x to the negative 1/2. That way finding the derivative is going to be easier. Don't have to use the quotient rule, I can just use the power rule. First derivative is going to be negative 1/2 x to the negative 3/2. If we find the derivative of that, which I like to call the second derivative, it's kind of a technical term for the derivative again, we're going to get 3/4 times x to the negative 5/2. If we rewrite that so it's in the original form, it's going to be 3 divided by 4 times the square root of x to the 5th. Please note, you can square root it and then to the 5th, or you can take x to the 5th and then square root it. Typically, for me, rooting it is less work and then raising it to the 5th. That depends on the problem though. So the second derivative evaluated at 4, we're going to replace the x in the problem with 4 and then simplify this. The square root of 4 is 2. 2 to the 5th is 32. 4 times 32 is 128. I don't know if you noticed, but I just looked up at the sky to determine what 4 times 32 was. Somehow tilting my head up and to the left. Yeah, for some reason I think more clearly. So this is the function evaluated, the second derivative evaluated at 4.